This is lesson 5.8. In this lesson, you will be making scatter plots and then fitting different models to the scatter plot, see which one fits the best, and then use the model to calculate values. So, to begin with, you need to set up your calculator so that the diagnostic is on. So, press the second button and then press the catalog button, which is the 0 button. You can't see it on this screen. And you should get a screen that says catalog, and then scroll down on that till you find diagnostic on and press enter twice. Throughout this video, if I'm going too fast, you're going to have to hit pause so that you can catch up. So once your diagnostic is on, you should be set to go. Okay, so first thing we're going to do is make a scatter plot of this data on the left-hand side here. So to do that, you will first go to Stat, which you see here. Go to Stat, and then you'll see a screen that says Edit. You press Enter on Edit, and it will bring up your two lists, and you can put your X values in list 1 and your Y values in list 2. Once you have those values in the lists, then we want to be able to see a scatter plot, so you're going to have to turn your plot on. So you'll first hit the second button right here, hit the second button, and then hit the Y equals, and you will see this screen. Set up your screen so that it looks like mine, so that the plot is on. You choose the first type of graph, and your X list and your Y list should be list 1 and list 2, because that's where you put your X and Y values. Once you have that, in order to make a decent sized window so you'll see all your dots, the easiest way is to hit zoom right here. Hit zoom first, and then number 9. When you hit zoom 9, you will get a scatter plot like this one. Okay, so once you've got your scatter plot, the next thing we're going to do is calculate a linear regression, a quadratic regression, and a cubic regression. So you have to do them one at a time. To do that, you will first hit the Stat button right here. Hit the Stat button. Once you have chosen the Stat button, you're going to use your arrow keys right here, arrow over till it says Calc, and then first we will choose linear regression, and then you will do the whole thing again, and we will get results like this. When you do the linear regression, you'll get a screen that looks like this, and your A value is your slope, and your B value is your y-intercept. So then you can plug it into y1, and when you hit graph, you'll get a line that goes through your scatter plot. Okay, one thing you should notice when you do your linear regression is you get this r squared right here. The r squared is called the correlation coefficient. And the correlation coefficient tells you how good of a fit your line is with your data. So a 0.55 is not a great fit. So then we try the quadratic regression. So you will go to, again, Stat, then go to Calc, and then choose quadratic regression. When you do that, you will get these values. So you get ax squared, bx, and c, which you can put into your y1. And when you hit graph, you get a graph like this one. Okay, looking at our r squared value here, we can see we have an r squared of 0.76. That's a better fit than 0.55. Actually, what you're looking for is an r squared as close to 1 as possible. And it can be a positive 1 or a negative 1, but as close to 1 as possible. So 0.76 is closer to 1 than 0.55, so the quadratic is a better choice. So then we can check the cubic regression. So again, you go to Stat, Calc, this time choose the cubic regression, and we get results like this. And this time we get 4 variables because it's a cubic equation. But notice our r squared is even better, 0.99. So you can put it into y1 and graph it, and you can see that this cubic curve hits a lot more of the points than the linear curve or the quadratic curve did. So this brings us to the n plus 1 point principle. The n plus 1 point principle says that if you have a given number of points, the equation that's going to fit it the best is an exponent that's 1 less than the point. So a quadratic, which is x squared, will fit perfectly with 3 points because that would be 2 plus 1. Okay, so to say that again, let's say we have 5 points. A quartic regression should fit that data set perfectly because x to the 5th power is, or x to the 4th power is a quartic, and that is, the exponent is n. So if you take n plus 1, that means 5 points will fit a quartic perfectly. So we have this data set. You can see there are 4 points. Since there are 4 points, well, first of all, I put it into my 2 lists. And then when I created my equation, I did a cubic equation because there are 4 points, so a cubic would fit it perfectly. And you can see the values here for A, B, C, and D. And then I plugged that into my calculator, and I graphed it. And you can see that the line fits the points perfectly. You can also see here that our r squared is exactly equal to 1. That's a perfect fit. Okay, here we have a story problem. It says Wisconsin dairy farms produced 16.5 billion pounds of milk in 1955, 22.4 billion pounds in 1980, and 22.9 billion pounds in 2005. What model best fits this data? So what I did was I took the data and put it into 2 lists. And I used the year 1900 as year 0. So 1955 is in here as 55. And 1980 is in here as 80. And then 2005 is 105 years after 1900, so it's 105. So I put my stuff in here. Then I calculated a linear regression, which looks like this. And then I calculated a quadratic regression, which looks like this. And as we can see from the r squared and from the curves, the quadratic fits the data perfectly. It's a much better fit. But if you use the model to predict the milk production in the year 2000, we would take our equations, plug 100 into the equation for x, and calculate. The linear model predicts that Wisconsin would produce 23 billion pounds of milk in 2000. The quadratic model predicts almost exactly the same thing. In 2000, Wisconsin actually produced 23.2 billion pounds of milk. So both models are good. The question is, which one seems more realistic? If you use the quadratic model that fits the points perfectly, you can see that over time the model predicts that milk production will go down. And that really doesn't seem reasonable. So the linear model really seems like a better fit, even though the quadratic fits the points perfectly. So you have to be careful when you're choosing your models. You can't always go by your r squared values. Sometimes you have to use a little bit of logic. Okay, these are just vocabulary words. When you use a model to predict additional data values, you can either interpolate or extrapolate. Interpolation is where you use the model to predict a y value that's inside of your data set, and extrapolation is where you use the model to predict stuff that's outside of your data set. And you have to be careful with extrapolation because the farther you get outside of your data set, the more likely it is to be inaccurate, like with the cheese production, or with the milk production. If you look into the future, it's going to predict that production goes down when reality is it most likely went up. So an example relating to interpolation and extrapolation. If we take this data set about cheese consumption and enter it into list 1 and list 2, we can calculate a quadratic regression or a cubic regression. And then once the cubic regression was calculated, I put it into y equals and I got this graph. And so you can see that the graph fits the data quite well. So now we want to use this equation to calculate future values or additional values. So if we use our model to predict consumption in 1980, you can see 1980 is not in our chart. So this would be interpolation because 1980 is within the range of our data set. So 80, I got this out of the table in the calculator. You just scroll down to 80 and it gives you your number. Or you can use your equation and plug in 80 for all the x values. Get the same answer. Next, we can calculate for the year 2000. And as you can see, the year 2000 is also within the range of our data set. So this would be interpolation also. And I just scrolled further down in my table. And I found in the year 2000, we're predicted 29, billion pounds of cheese. Or you can put it in your calculator by substituting 100 in for all the x's in the equation. And then finally, we're asked to predict for the year 2012. So in the table, you can just scroll down to 2012, predicts 46 billion pounds of cheese. Or we can substitute it into the equation, and we get basically the same answer there. But 2012 is extrapolation because it's outside of the range of our data set. Our data set only goes up to 2001, so 2012 is way outside that range. So we would not have very much confidence in our prediction for 2012 because it's too far into the future. Okay, so that's it for using your calculator. I will post this on Moodle if you need to see it again. And you should have already watched your 5-9 videos.